There we go. Now it's focused. So please make sure you understand all these problems. And in addition to what you see in this practice, make sure you're aware of all your mistakes in your quiz. Okay, so hopefully we can show improvement from the quiz to this chapter 1 exam. So the first thing I'm asking you to do is to graph 3 points, and then this will form a triangle, and we want to know the perimeter, the distance around that triangle, and then we want to know the area of the triangle. So let's quickly plot 2 up, 1, 2, 3. There's my A. Okay, everybody should be able to plot points. Then we're going to plot 6 up, 3, 1, 2, 3. That's your B. And finally, we're going to go 4 down 2, 1, 2. Okay, so it looks like we have a triangle like this. So from A to B, so the distance from A to B, you can just look at, count the blocks. You could also look from this point, both y values are the same. So I know the distance is the differences in my x's. So it's always the absolute value, so it's always positive. I know that's 4. 4 units is the distance from A to B. Now from B to C, so from B to C, we must use the distance formula, which tells us simply subtract our x's. So if you can do this in your head, do it in your head. 6 minus 4 is 2, but then you're going to square it. So it's going to become a 4. And then be careful here. If you need a calculator, use a calculator. You're taking 3 minus -2. So think about this distance. You can count down, and from B to C down, it's going to be 5 units. So it's going to end up being 5 squared. So really you have the square root of 4 plus 25, which is root 29. Okay. And then we need the distance, and you're going to see it's going to be an equilateral triangle. You don't need to know that now, but I'm going to show the distance from A to C. So when we do A to C, you're going to see that also is a difference of 2. 2 squared, we're going to get a 4 again. And then 3 minus -2 is also going to be 5. So we're also going to get root 29. So for the perimeter, all we have to do is take our calculator, because I want you to round this properly. Okay, so just like in big ideas, let's round it to 2 decimal places. So I have my 4, that's the only nice side. Let's make sure you can see this. Plus root 29, push away, plus another root 29. And the calculator tells me the distance is about 14.77 units. Oops, units, I can spell. There you go. Okay, so now area, I already know the base. So think from A to B as your base. And so area is going to be 1/2 the base, which I know is a 4. And then the height, go from C straight down, and you're going to see 1, 2, 3, 4, 5. We're going to know that the height of that triangle is going to be a 5. You probably do this in your head. That's 20. Take half of 20. You're left with 10 units squared. Okay, so make sure you understand where those numbers are coming from. Okay, that's a triangle. Okay, I had to quickly edit this because for G, it's -6 up 2. So here's my point G, and H is going to be 2, 2. I did not see the points correctly the first time I did this, so I had to go back and stop this. So that's the dimensions of your parallelogram. So from E to F, it's real easy to calculate. So distance, so the measurement of segment E to F, since my y value is the same, I take the differences of my x's and do the absolute value. So I know that's 8. Okay. The slant here, both are the same, E to G, same as F to H. So I'll find the measurement from F to H, and that is the distance formula. So from F to H. So from here to here, you're going to see 5 minus 2 is 3, but then when you square 3, it's going to become a 9. And then when you do 5 minus 2 again, you're also going to get a 3, but 3 squared is 9. So you're going to have root 18. Okay, I need you to understand that. So let's find the perimeter first. So the perimeter, we know this is 8. So you're going to take 8 plus this side is root 18. Now you can just add those together and double it, but I'm just going to show all 4 sides. We also know that this is 8. And then finally, to complete your quadrilateral, we'll have another root 18. So I'm simply going to add all these together. 8 plus root 18. Like I said, I could hit enter and then just double this number, but I'm going to type the whole thing in. Whoops, and I messed up. Delete. There's my plus sign. So root 18 plus an 8 plus root 18. And we get a distance of 24, and I'm going to say 0.49. So 4, so if you're rounding to the nearest penny, since next to the 8 is going to be a 5, I'm going to round that 8 to a 9. There is the distance around. So now as far as area of a trapezoid, I have the base. So area is the base, which we know is going to be 8, and then we need to know the height. So if I just drop from down here, that's going to be real easy to tell the height of this is just 3 units. So area, base times the height for a parallelogram. In this case, it's 8 times 3, which will result in 24 units squared. Okay. You could also look at from here. So like right here, 1, 2, 3 is the height, okay, which we know is 3 blocks. Okay, so hopefully that makes sense. You did a lot harder problems for the big idea assignment. So if you were able to get most of those and understand that, the ones on your test will be a lot easier than the ones you had to practice in big ideas. Okay. Next thing, I'm hoping that you find this to be pretty easy. So it's just like adding segments, like the segment addition postulate. We do the same thing for angles. So I am telling you, this big angle, ABC, is an obtuse angle of 114 degrees. So that means if I add these 2 angles together, it should equal 114. So that's how we're going to solve for x. So the first thing I want to do is solve for x. 6x plus 2 is the first angle. 2x minus 8 is my other angle, and I know it's going to equal 114. So first thing we're going to do is simplify this left-hand side. Everything's on the same side, so I just simply combine like terms. 6x plus 2x, that's 8x. 2 plus negative 8, or think of 2 minus 8. If you need a calculator, type that in. You get minus 6. Now I need to send this over to the other side, so I'm going to add a 6. 8x equals 120. I divide, and when you divide 120 divided by 8, you're going to get a nice answer of 15. Okay, now please don't stop there, because basically what I'm asking for is, what is the measurements of this angle? So angle ABH. And you can do that on a calculator. Now that we know that my x is 15, where I see the x, I put a 15. And just like that, we know this is 92 degrees. Now I could just take 114 minus 92 to find the other angle, but I'm going to type in 2 times 15, because 2x, minus 8. And we're going to get 22 degrees. Okay. There we go. And like I said, the whole thing from angle ABC, and we can easily, if this was a test, you really wanted to make sure, take the 92 plus the 22 and prove to yourself that it does add up to the total, which in this case is 114. Okay. The next example is the fact that we're dealing with a straight angle. We have to know that this is 180 degrees. These are also supplementary angles, two angles that add up together to equal 180 are supplementary angles. So it's very similar to the previous problem. We're going to take the two smaller angles, the 2x plus 5 plus the 3x minus 10, and we're going to see that it has to equal 180. Okay, seems pretty easy. Add your like terms. Add 5 to both sides and divide by 5. So 185 divided by 5, that's going to give us a 37. And if this is 37, if x is 37, then it's really easy to take 2 times 37 plus 5. Know that this is 79 degrees, okay, which will leave us 101, but I'm going to show where we get the 101 by taking 3 times the 37 that we got for x minus 10. And we definitely get 101. Okay. That is the completion of the first page. And hopefully all these problems make sense to you. Okay, for question 5, we are now told that we have an angle bisector. Okay, so we're told that ray BH bisects angle ABC. So that just tells you these two angles are equal to each other. So when you see this problem, you take the one angle, set it equal to the other angle. And then hopefully this is something that everybody, you have the basic algebra skills to be able to solve this. So I want my x's together. So I'm going to bring these x's over. Okay, so I'm going to pick up the 6x, do its opposite, so it appears on the other side by subtracting 6x. And then I'm going to add 36 to both sides. So when you do that, you're going to end up with 18 on the left and a 2x on the right. Divide by 2. And just like that, we'll know that x is 9. Okay? And then if x is 9, because I'm asking for HBC, both of these are going to be equal, but so I'm going to take my calculator and I'm going to take 8 times 9, because that's my x value, minus 36, and I'm going to see that we get 36. Okay, so both of these have to be 36. Now, just make sure you answer the question. So if I asked, hey, what's the measurement of ABC, angle ABC, then I have to add these two together, and then you would get 72. But the answer to this question is 36 degrees. Okay? So now, when you take your test, you have to know that complementary angles add up to 90. It's a super easy question if you don't get this confused. So when you see complementary, you subtract from 90. So if I tell you one's 43, all I have to do is take 90 minus 43. Some people can do that in their head. And you're going to know that angle 2 has to be 47 degrees. Okay? And then if you see the word supplement, you're thinking 180. So 180 minus, in this case, 103. And when you do that, you're just going to get 77 degrees. So the measurement of angle 4 has to be 77 because these two add up to 180. Okay? So now this, hopefully you looked at the problems in our notes. You need to know that a pair of linear basically are supplementary. It forms a line. Okay? So I have this, and I have one ray coming out. So these two are linear. and we said that the measurement of one angle is 3.5 times the measure of the other angle. So I'm just going to call this x. Okay, my smaller one x. The bigger one we're told is 3.5, so 3.5 times whatever x is. Okay, so we know that when we add these two things together, it has to equal 180. Okay, so 3.5 plus 1 is 4.5. And I'll take my calculator and I'll just ask the calculator what's 180 divided by 4.5. I'll know x is 40. So the one angle is going to be 40. And if I wanted to know what the other angle is, and we're supposed to find both. So this one is 40 degrees. And then I'm just going to multiply 40 times 3.5. And I'll know the other one has to be 140. Plus, quickly add them together, and they have to be 180. Okay? So now this question, super easy. Two angles that are vertical angles. So vertical angles, like here is an example of a pair of vertical angles. Okay, when two lines intersect, they create pairs of vertical angles. So if one is 37 degrees, that forces the other one. They are congruent. Vertical angles are congruent to each other. So real easy to know that the answer is 37. Okay. And the last problem on this page, we want to write all the possible names for the given angles. Okay. So easiest thing is if you have just a letter as your vertex. So I can call this angle B. That's one way. When you have a number inside, I can call it angle 3. And then my other options then is to use 3 letters where the vertex has to be in the middle. So I can go A, B, C, and make sure you have the angle symbol. Or I could start with the C and say angle C, B, A. Okay? All different ways of referring to the same angle. Okay? So now here for this one, we can't refer to angle B because again, there's more than one angle that has a vertex of B. So I can look at this angle, so angle A, B, D, which is the same as angle D, B, A. So that takes care of naming this. Okay. Then I could look at this other one, which is angle DBC, which is the same as CBD. Okay. Then finally, I have this big angle, which I can say ABC, which is the same as CBA. Okay. So all different names for all the angles, and that takes care of page 2. Okay, for page 3 of this practice test, make sure you know how to classify a polygon based on the number of sides. So all you have to do on the test is count the number of sides and then name it according to that. So in this case, if you count the number of sides, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, you're going to know that that is a dodecagon. Okay, so there's a dodecagon. And then I'm also asking you to classify it if it's convex or concave. So this is convex because no matter where I put a straight edge along a side, it's not cutting to the inside of your polygon. Okay, so this is clearly convex. So it's just terminology that you're forced to know. For the next one, you count up 1, 2, 3, 4, 5, 6, 7. 7, you're going to have to know is a heptagon. Heptagon. But then this, if I would cut, make a straight edge to this side, it's cutting inside. So that's one example. If I go this way, it's cutting inside. So it is concave. So make sure if you see 8-sided, you're going to call it an octagon. If it's 5-sided, you're going to call it a pentagon. On the test, 6-sided, hexagon, just go back to your notes and make sure you understand that. Okay. This next part, I am not going to make you use an actual protractor. You're just going to be referring to the protractor I have on your test. Okay. So it'll be built in to the problem. And just make sure you know what angle I'm asking for. So in this case, I'm asking for angle BOC. So since we're not starting at 0, I have to look at these measurements. So this one ray has a measurement of 50. This other one has a measurement of 30 degrees. So obviously it's the difference. So this is going to be 20 degrees. And we know anything less than 90 is acute. Okay. The next one I'm asking for E. So let's find E. EOA. So it's this right here. Okay. The good news is I do start with 0 here on this side. Okay. But then you need to realize this is up to 60 degrees would not make sense for this problem, this angle. That's obviously more than 90. You look at the inside numbers, and in this case, it's 120 degrees. That makes it obtuse. Okay. So then the next thing, you just have to make sure you're aware of some terminology for angles, like identifying, in this case, vertical angles. So I need to know, find angle 10 and the angle, so two lines that intersect form vertical angles, 10 and 12. So angle 12 is what I'm looking for. Okay. For linear pairs, we need to make sure it's two angles that are next to each other and are 180 degrees, okay, that form a line. So we're supposed to include all the linear that includes angle 9. Okay, so angle 9 and 6, that's a pair. Angle 9 and 8, that's a pair. Okay, that's all I'm asking you to do. Okay, so then this next part, we want to identify all the congruent angles. So use these symbols. Okay, so we know angle R is congruent to angle A. Okay, they have the same symbol for the angles. We know angle S is congruent to angle B. Okay, and then finally, angle T, it has the 3, 1, 2, 3, 1, 2, 3, is congruent with angle C. Okay, so that's the first thing I wanted you to do, was identify all the congruent angles. And then the next thing is, if angle R, so this is another name for angle R, if we know this is 30, and then angle A would also have to be 30 degrees because they are congruent. Okay, so hopefully that page was pretty easy and that you understand everything on so far on this practice. Okay, last page of this practice, we start off by telling you that CBH is 100 degrees. I would fill that in. Okay, and we know ABH is 25 degrees. Okay, so then this next part, they tell you SQP is 80, and then SQR is 65. So we need to see those angles so that we can then answer the questions. So we need a pair of complementary angles, okay? Two angles that add up to 90 degrees. So if you look at the 25 and 65, 25 plus 65, that's going to give you the 90 that we need. So you just want to name these properly. So angle ABH and angle SQR are complementary angles. Okay. Then supplementary angles. Okay. Add up to 180. Okay, and hopefully you can see right away, you have 100 and you have 80. Obviously that adds up to 180. So we want to, again, name these properly. HBC, HBC, and angle SQP. Make sure you're using the angle symbol when you're naming angles. So name a pair of adjacent angles. So there's quite a few. Okay, so again, next to. I shouldn't say there's quite a few. There's two. So we have one pair that's going to be ABH. So I'm going to write ABH. And right next to it, they share a ray, is angle HBC. So that's one pair, and that's all you would need. I'm going to also list the other pair. This other diagram has PQ. You can see PQS. So these are a pair, and then PQS and angle SQR. They are next to each other. Okay, that's all adjacent angles mean. Okay, so then this last one, I do have you take a protractor, so just practice. So when you're using a protractor, you can extend, okay, especially this size protractor. I'm going to extend this. So this ray, I'm going to extend up so that when I place my protractor, I can see. So you want to make sure, and I could even extend it a little bit more. You want to make sure it's lined up with 0, and then this ray extends, and I can see it's right around 60. I think it's a little shy of 60. So I'm going to say it's about a 59-degree angle. Okay, let me make this one longer just so we can see. So try to make it as straight as possible. So like that. I line this up and I make sure this is going through, this ray is going through 0. And then now I'm looking at this. I use the outside because this is definitely obtuse. So I'm going to say it's about 121. So 121 degrees. Okay. So hopefully you understand every single problem on this. Look back over your quiz. I have a video where I went over all the answers to your first quiz. Make sure you understand everything that we've done so far. Again, chapter 1 is the basics. We're laying a foundation for what's to come. So we need to know these basic terminology, how we state rays, how we state angles. So hopefully chapter 1 made sense. If you have any questions, please reach out to me. Thank you for watching. Take care.